Hello, everybody. Welcome to Data Umbrella's webinar. So our process is usually I do a quick introduction. Matti will do his talk, and we'll open it up for Q&A. If you have questions, you can post them on chat, or you can post them in the Q&A tab. I can easily move questions from the chat over to the Q&A, so that's fine. And this webinar is being recorded and will be available on YouTube, usually within a couple of days, but sometimes a week, depending on how much editing has to be done. A quick introduction about myself. I'm the founder of Data Umbrella. I'm a statistician, data scientist by training, and I am available on Twitter, LinkedIn, and GitHub at Reshama. So feel free to follow me if you'd like. We have a code of conduct here. We're dedicated to providing harassment-free experience for everyone. This applies to the chat of this webinar as well. Our code of conduct, you can link to it on this, link to the sticky pad if you want to go to it. Thanks for making this a welcoming and friendly community for all. If anybody does sort of put something inappropriate in the chat, we will remove that person from our community. And to let you know that we are a volunteer-run organization. There are various ways that you can support our community. The very first way is to follow our code of conduct. We want to make it a welcoming and inclusive space for underrepresented persons. And so following our code of conduct and contributing to making it professional is like our top priority. Otherwise, you know, it could be like any other community. We have a Discord community chat, so feel free to join it. It's on our website. It's a place to ask and answer questions there. We have an open collective where people can donate to cover our operational expenses. And we also have an initiative, this video, to do a transcript that will be available for people to read later. The location of the transcript is on GitHub, Data Umbrella event transcripts. You can also find transcripts for past events there. We have a job board, which is at jobs.dataumbrella.org. Check it out, just if you're curious or if you're on the market. On our website, which is dataumbrella.org, we have a lot of resources for open source, for accessibility, for responsibility, social impact of AI. So please check it out later at your convenience. We also have a monthly newsletter, which is at dataumbrella.substack.com. I'll copy the link and put it in the chat later. We send out a newsletter once a month, so feel free to subscribe. We promise not to send you spam. We are on all social media platforms as Data Umbrella. The best place to join really is our Meetup group, because that has our events in it. And then there's, you know, we're on Twitter and LinkedIn and also YouTube. So this is being recorded and it'll be uploaded to YouTube. So you can check out our past events there as well. And if you subscribe to YouTube, you get this notification on your phone, which is useful. We have two upcoming events. We're going to have a Contributing to Pandas webinar on December 15th, so you can find it on our Meetup page. We also have a command line setup environment, which is on January. So, you know, there's more information on the Meetup group about these events and signing up for it. Today's speaker is Matti Picus. I hope I'm pronouncing that right. Matti is an active contributor to NumPy and a member of the steering council. He is also a core developer and release manager for PyPy. He also contributes to maintaining the scientific Python stack across the ecosystem of packaging, CI, which is continuous integration, and documentation. Since April of 2020, in this year, he has worked at QuantSight Labs, and you can find him on GitHub at Matti P. And with that, I will turn off my video and I will hand the floor over to Matti.
Great. Okay, here we go. So my talk today is how to get involved in NumPy. As Rashida said, my name is Matti Picus. This presentation is in a Jupyter Notebook. And when we put up the YouTube video, we'll actually link to that notebook as well. I'll be tabbing around my web browser a bit. Hopefully the lag won't be too bad and won't make you too dizzy. Use the chat and the Q&A. There's some ringers in the audience, some other NumPy contributors, and they'll be happy to answer your questions as we're going along. And my goal, and the reason that we'd like to talk to you today is to get you started with helping us with documentation, tutorials, code, and DevOps. So NumPy is much more than just the code itself. We have other ways you can contribute. So what are we going to do? First of all, don't panic. The project itself is huge. It has lots of different corners. And I'm going to talk about some stuff. And if it doesn't make sense, that's OK. We're going to have a brief history of NumPy. When was it started, by whom, and what for? What drives NumPy? What are the goals, and how do we decide on those goals? Who decides what happens in the community? We're going to talk about communication channels and ways you can get in touch with us and the different repos there are on GitHub. And then we'll demonstrate how to build and test NumPy. And then we'll take a look at at how to find issues and PRs that contributors can work on. And then at the end, we'll take some questions if there's still time. But first, my name is Matti, as I said. I'm a QuantSite developer. QuantSite is a company that of about 80 and 90 developers working both in open source and for contracted work. I was previously employed by the Berkeley Institute of Data Science to work full-time on NumPy. I did that for 2 years before I joined QuantSite. And I'll talk a bit more about that later. I'm an avid open source evangelist. I believe in open source. I think that's the best way to produce quality code and software. PyPy is a project to implement Python, but not via C, actually via Python. So it's Python that implements Python, just like the C compiler is written in C. If you want to know more about that, you can find out about it on pypy.org. I believe deeply in the power of community. That's why I'm doing this talk. That's why I've been working on open source for the past couple of years. I spent a long time in an intentional community in Israel called kibbutz, spent over 10 years there. And I think that community is the way that society should be organizing itself. And I also believe in diversion and inclusion. I was lucky enough to have a very smooth course in my life. Not everybody else does, and I'd like to help others move on and become able to contribute to society, tech, and open source in particular. Okay, so back to the talk about NumPy. NumPy, as you can see here in 2006, was started by Travis Oliphant. It grew out of two other libraries, Numeric and NumArray, as a way to synthesize those two libraries together. And it was the cornerstone of what Travis actually wanted to build, which was SciPy. So NumPy sits under SciPy, and it turns out NumPy sits under a lot of other things as well. As time went on, the NumPy API and the NumPy way of looking at a chunk of memory and dividing it up into items became very popular, was adopted by the deep learning frameworks, by a library called CuPy, which allows you to do NumPy-like operations on data on your GPU. Dask and Sparse also use it. Also use the API and the ideas behind NumPy as well as NumPy itself. NumPy is quite popular. Pretty much it's the first thing that people will install if they're doing data science and they want to, they're building a Python environment. We estimate that it's got tens of millions of downloads and users worldwide. And it's maintained now by about 10 people. That's a bit of a stretch, maybe 6 people actively. Maybe full-time equivalents of about 2.5 or 2 people. It's over its lifetime, it's had $1.4 million US dollars in lifetime funding. About over $1 million of that was donated by the Moore and Sloan Foundations in a joint grant that I was lucky enough to participate in. It started about 2.5 years ago. They hired about 3 developers to work on NumPy full-time for 2 years, along with some other things, and that really gave the library a boost. The infographic below shows how NumPy is used pretty much everywhere, but of course you all know that. Okay, that was the brief history of NumPy. Now we'll talk about what actually is NumPy. How do the core people who push NumPy forward, what do they think the goals of it are? So, as I said, this is all a Jupyter Notebook. I'm just using the website here because I'm too lazy to actually write stuff by myself. So if you go to the website, you can read about what NumPy is. NumPy is run by a steering council. There's about a dozen people on the steering council. The steering council is a loosely appointed, self-appointed group of people who are currently the active contributors to NumPy. And they're the ones who will decide what direction the project will take. NumPy is made up of a bunch of overlapping teams. We have teams for, it might be a bit small here to see this, but we have teams for code, documentation, the website, for triaging bugs and issues, and a small team for getting funding and grants and administrating the project. And we also have a small number of sponsors. I already mentioned the Moore and Sloan Foundations. Chan Zuckerberg Institute's initiative has been active in the past couple of years, giving us some grants, and Tidelift gives us monthly support. And both of these industrial partners, institutional partners, I've been lucky enough to work at over the past couple of years. So how do we decide where we're going to go with NumPy? So if you look at it from the top down, we could look at it from the bottom up. We're going to do that as well. But if we look at it from the top down, NumPy it's higher level goals. And when we look for funding, what we're trying to do is to get actually funding for our roadmap. The roadmap describes the scope of NumPy and our wish list of features we'd like to work on. And then enhancements, large chunks of future work on NumPy will be done through NumPy enhancement proposals, or NEPs, N-E-Ps. These are proposals to change things like the D-type system underlying the array object, or the random number module that was in NumPy, or one of the latest ones that's to make all the functions in NumPy use processor intrinsics. Okay, so that's kind of the higher level view, but what does NumPy think about itself? NumPy is a very nice way to work with a chunk of memory on CPU with stride, shape, and D-type. And one of the most important things that we as developers take to heart while developing NumPy is not to break anything. We have a strong commitment to be backward compatible and not to break people's workflows. We realize that NumPy is a basic core piece of the data science stack in Python, and we're trying to be careful not to break things. While performance is important, interoperability beats performance. As I said before, NumPy was started as an initiative to be one piece in a larger puzzle. We realize that is a deep commitment, and that's part of what NumPy views itself as doing, is being at the forefront and at the base of a large number of Python array type objects, and driving that forward so that people can do things with NumPy that aren't built into NumPy, but enable interoperability with other libraries. So what do I mean about interoperability? Don't worry if this is a bit of a deep dive and you miss a bit of this. It's more of a higher view of how, just trying to emphasize how NumPy wants to work nicely with other libraries and to interact with other libraries in a nice way. What goes into NumPy is actually very tightly controlled. We try to keep many things out of NumPy, provide only the minimum tools needed to work with the basic library that NumPy is, and would rather delegate other tasks to other libraries that can move a lot faster and maybe break things where NumPy has to be careful not to break anything. So one of the things that's in NumPy is an extension to distutils, which is a tool to build libraries. But things like optimizations, which are in SciPy, or loading images, which are in scikit-image and Pillow, or working on the GPU, which are in CuPy and JAX, they won't ever, hopefully, come into NumPy. It's hard to say never, but they probably will never come into NumPy. There are pieces of code that are in NumPy for historical reasons and probably shouldn't be. One is a minimal FFT implementation. The one in SciPy is much nicer, as is the linear algebra routines that are in SciPy. They're much better thought out. Polynomial and F2Py were two pieces of code that are kind of orphans. No one really wants to take care of them, and so they've stayed in NumPy. And the random module that's in NumPy is a best of brand random number generator that we're very proud of, and it is in NumPy, but you might think that it doesn't actually belong in NumPy. It doesn't actually go with the core mission of NumPy. In addition, NumPy provides throughout its code a way to take this ND array object that I talked about that has the chunk of memory on the CPU with strides and shape, and allows you to subclass it via different protocols. The dunder array protocol, dunder array wrap protocol, dunder array struct protocol, dunder array priority protocol. All these are useful for subclassing ND array in a way that doesn't actually, it overrides the behavior of the ND array, but it doesn't affect the code in NumPy itself. So it's another way we can interact with others. Then we determined that these were not enough. We need more ways for people to be able to override things in NumPy. And so we provided 3 new protocols, the array ufunc protocol, the array function protocol, and the array module protocol, to also make overriding functions transparent. So all those protocols are the reason that you can do something like the code that's on this page. You can do import NumPy as NP, import CuPy, which, as I said, was the library that allows you to work on a GPU. You can create a CuPy 0 array by 10 by 10 of the D-type NP int, and then you can call sum on that. Now, when you call sum on that, that's actually calling the sum method on this A object. But if you call np.sum, that's calling a procedure from the NumPy array. But because we have protocols, you can override that, and that actually calls back out to CuPy to provide their function. As well, you can override functions. Okay, sum is a ufunc, if that means anything to anyone. Mean is a function. You can also override that with array function. And lately, our last step in this procedure, and one that will be out in the next release of NumPy, hopefully next month, will be the like keyword, which allows you to actually create a new array just with the same device type and same kind of format as A. So all this needs a lot of fun working underneath the hood in NumPy to make all these things work. Even that is not enough. So NumPy, together with the other data libraries and together with some industrial partners, have started to set up what we're calling a common API for arrays and tensor Python libraries. So this will cover both NumPy and pandas type objects, the pandas data frame. And the idea is to create a common API so that anyone who wants to create something that can one-for-one replace NumPy will be able to do it. So rather than import NumPy, you may do import my fancy library. And as long as it implements all of these API functions, you will know that it is NumPy compatible. Okay, so I hope I've convinced you that NumPy tries to be interoperable with a lot of other libraries and tries to be a good member of the community. And now let's actually talk about contributing to NumPy and working with NumPy. Like most of the world, NumPy has moved to GitHub. Most of our activity takes place on GitHub. We also have a mailing list, NumPy discussion for bigger topics, ones that can't be neatly packaged into an issue or a pull request. So how does that look? Let's take a look at the NumPy organization on GitHub. We have 3 or 4 different repos. We'll go through them really quickly to see which ones do what. So the top repo in the hierarchy is the actual NumPy/NumPy repo. That's where the code and the documentation for the NumPy library live. The archive, the reason it's on top is because that's where I put my talk just now. That's where it's been archived, and that's where it's you can find it. So that's where it was updated half an hour ago. That's an archive of all kinds of presentations and talks and logos and branding about NumPy. NumPy tutorials is a new repo that we've started in the past 6 months to actually aggregate best of brand tutorials on how to work with NumPy, things we recommend, and ways we recommend that it all work. NumPy.org is the NumPy website repo. And then the only other one that I want to call out in this long list is the NumPy doc repo, which holds an extension for Sphinx. Sphinx is a way to document Python libraries. It builds a lot of the documentation that you'll see if you go into Python package documentation websites. You'll see documentations that have been built using Sphinx. NumPy doc is a way to turn doc strings from Python functions into nicely formatted documentation. Right, got it. Okay, so that's how you kind of wander around the GitHub NumPys. How do you actually build and test and get involved in working with NumPy, the library itself? Not import NumPy and then working with it, but actually building it and testing it. So NumPy has a nice long contributors guide. Okay, it goes through the whole development process with a summary of how to actually create a pull request, how to build, how to test, what kind of stylistic things you can use, how to build the documentations, and then even more detail in subsequent web pages. But you guys are all lucky I'm here. So we're going to do this together. We're going to go through and create a directory to work to actually build NumPy. We're going to create a conda environment to build NumPy. We're going to clone the repo, and we're going to actually build NumPy. So let's start. Here I've got a terminal. It's a bit small. Let me try and copy paste the commands from here, because copy paste is a developer's dream. And it didn't copy. Make dir temp dm test. Okay, and cd temp dm test. They always say never live code, right? And then I want to actually create a conda environment. So I'm going to create a new conda environment called data umbrella using Python 3.8. The paste didn't quite work. This is why they say don't live code. It's going to take a second to actually resolve all that, and we'll tell it to go ahead and create that environment. I like working in a virtual environment. That makes my code, makes my Python environment clean. I know exactly what's in it. And now I'll activate that environment. Umbrella. Okay, now we've got a conda environment activated. You can see that it's called data umbrella. And we're going to clone the NumPy repo. Git clone github.com, https, github.com, numpy/numpy. Okay, and while that clones, let's go back and look a bit at the repo, at what we're actually pulling down into this directory. So if we go into NumPy, this is the directory we're cloning right now. You'll see that there's a lot of different files here, starting with the README itself that asks for contributions. So among these directories, the two that are really where we like to work in are the doc directory and the NumPy directory. Because we're going to try and build NumPy, let's take a look at the NumPy directory itself. We'll dive in and see what it looks like. Oh my goodness, there's way too much here. So there's a whole bunch of directories here. This is a mixture of Python and C code within one directory structure. You'll see things like f2py, which I talked about, which is a library that allows you to use Fortran in Python, or random, or distutils, which is a collection of improvements to distutils so that it compiles better. The one we care about is where the C code actually lives, because NumPy is built in C. Underneath the Python, a lot of it is Python, but much of the code is C. And that's in the core directory, in the source directory. This is where the actual code itself lives, that we'll be working with as NumPy contributors. Originally, NumPy had two different structures, two different extensions that were built. They've been unified together. One is multi-array and one is UMath. Multi-array is the thing that holds the ND array. So this is the actual code that builds that ND array object. It looks a bit scary, but as we'll see as we try and work through an issue, it's not that horrible. Okay, so we've successfully cloned NumPy. Now we'll cd into the GitHub checkout. And the next thing we want to do is build and test our new checkout of NumPy. So we do Python. The way you can build that people traditionally build a C extension project within Python, within the Python world, is with Python space setup py. NumPy has a convenience function called run tests that, surprise, surprise, runs all the tests. So it builds and runs the tests of NumPy. There's different ways you can run it. This is all documented on the website under that contributor guideline. If you just run tests, which is what we're going to do in just a minute, it will build and run all of the tests that NumPy has, probably around 12,000, 14,000 different tests. If you run it with a -s, it will only test this module, and if you run it with a -t, it will only test this particular test. Because, as I said, NumPy is a C extension module, there's challenges when you want to build it and test it in place, when you want to run the actual code that you built. So you have this directory, and when you build the project, not necessarily Python knows how to import it from that directory. So run test sets everything up in a way that you can do run test ---ipython or run test ---python, and then it will set up your environment so that you can import the newly built NumPy every time you build it anew. We also have benchmarks within the test suite, and you can run the benchmarks to see how your code has affected the performance of NumPy. Okay, I won't go through everything that's in the run test. It's way too much to go through, but let's try running it. The only argument I'll give it is show build log, which will show the compilation as it's going. Ah, I didn't do something. I didn't read the instructions. Let's go back to the instructions. What didn't I do? I didn't install everything we need to actually build NumPy in our Conda environment. So let's paste that command. there's a file that has all the requirements. We'll install that. And now we should be ready to go. Okay, so the first thing it does is process Python, which is a library that takes Python-like code and turns it into C. And now it begins to compile the NumPy extensions. You can see it does a lot of compiling things. While it does that, we'll take one more look at the directory structure. Okay, I said there were two main pieces of the code itself, of the NumPy repo. There's the NumPy code, and then there's the documentation. We take our documentation seriously. We like to have clear and concise documentation about everything that NumPy does. This is where the documentation lives. Just like in NumPy, where there was a source directory, here there's also a source directory. And the documentation is written in a format called RST, restructured text. And the restructured text heavily uses the Sphinx tool to automate a lot of the building things. So if you look at, for instance, the index page of the whole library, all you'll see is that it's got a talk tree, which is a table of contents, and then it refers to other pages. And these other pages will actually be pulled in, and Sphinx will help us create from this a nice HTML library. So let's see how we're doing. Still compiling. Okay. Let's move on a bit, and we'll come back to the tests. We'll come back to see how the run went in a little bit. So it all looked very clean and very easy for Linux. That's usually the way the world works. But if you're on a Mac OS and a Windows, there's a few things you might have to look out for when you're starting to build NumPy. Mac OS is pretty close to Linux, so it's pretty smooth. You may have some problems with the accelerate library, which is linear algebra library that NumPy by mistake will pick up. It has bugs, and NumPy won't let you use it in its compilation. So you'll have to find a way to neutralize that library. There's some tips in our developer guide. On Windows, you're going to have to install a compiler. Once you've done that, it should just work, hopefully. Okay, much of the code base is written in C, and it's not. We don't use C++, basically because we support some very old compilers. As I said, we try not to break things. That means that because it's written in C, you need to know something about the Python C API and how ref counting works. Ref counting is a way around the problem that Python has in object initialization and throwing things away. So objects in Python live in a scope. If you're writing a Python code, you'll see that the object lives within your little local scope of your code. And when the object goes out of scope, Python is very clever about destroying it. In C, we don't have that option. Once you create something in C, you're the one who are responsible for destroying it or for deleting it. Another trick that we use in NumPy is that a lot of the C code is actually generated either from Python or from other C code in a templating kind of way. If you hit that, then you'll have to learn about it. Building documentation. We talked about documentation and how important it is to the NumPy ecosystem. Because our code is self-documenting, you have to have the version of NumPy that you want to use, we want to actually document, installed in order to use it. So this might be a little bit of, there's some tricks you have to learn to work around this when you're compiling NumPy and then trying to work on the documentation itself. The two versions have to agree with each other. As I said, the doc strings, the code is self-documenting, so the doc strings for C extension, they're injected from Python. Let's see how that works. We have a Python file. Oops, not that one, this one. We have a Python file called add docs, add new docs. that adds the documentation to the C extension modules when you import NumPy. So let's go down and see how some of these look. If NDItter, probably it's not a function a lot of people use, but here's the documentation for NDItter. It's written in RST, in this restructured text, within Python. So it's got the triple quotes to turn it into a docstring. The first line is the one-line summary of what the function actually does. And then there's a longer summary. And then the documentation is written in this very special format that NumPy docstrings use, and then is parsed and turned into pretty documentation. Okay, let's go back and see how our test run went. Went pretty well, okay? It finished compiling. I'll go back, I'll scroll back up. This is the end of the compilation, and then immediately it started to run the tests. People who have used PyTest before, this is a PyTest output of all the tests that NumPy is running, and everything was green. There's some tests that are skipped on different platforms, and different operating systems will use different testing strategies. But everything ran that could run here, and all the tests passed. It skipped out a bit on the screen here. Let me see if I can get that there we go. Pops up a bit. We had about 13,000 tests pass in a little over a minute. 85 seconds. Okay, great. So we've moved on. We've looked at a bit of code. We've seen how we build NumPy. Now let's take a look at how you can actually dig out a issue or a pull request. We have about 10 minutes left before we'll take some questions and answers, to try and look through and find some issues you can work on. Typical workflow in NumPy is much like the other lectures you've heard or the other talks you've heard in this series. You want to add a failing test. We do test-driven development. The idea behind the failing test is you probably just take it right from the issue, put that failing code into a test in the proper place in the test structure, run the test as I did, and your test should fail. The next thing you need to do is find out where that function is implemented, and then you have to start from there to figure out what's wrong, what's going on in that function that trips the test. Then, of course, you want to try and fix it. Then run all the tests, not just that one, to make sure you didn't break anything else. Very important not to break things. Then you can push a PR and interact with people. So the work doesn't end when you push the PR. That's only really the beginning. That's when the actual work itself starts. Your work will get a review, a very careful review. Some people would call it nitpicky. And then you need to react to the comments on that review and push it forward until it gets through. If it's a simple pull request, maybe the whole process could take a week or two. If they're complicated pull requests, well, let's take a look at what happens to complicated pull requests. It's not easy to find good first issues in NumPy, and let's open that up and take a look at that while I talk about why it's not so easy. We have over 2,000 issues in NumPy and about 290 open pull requests. Now, we'd be very happy to get that down to 0 on both ends, but there's a lot of reasons we don't. If we take a look at some of these issues, and if we sort them by least recently updated, let's say, and we look at something that some of these issues from 6 years ago or from quite a long time ago, the reason that we haven't solved these issues is we don't really know how. As I said, we're very careful about not breaking things in NumPy, and a lot of these issues are good ideas, but they would change the way NumPy works, and so we can't do them. Same thing with the pull requests. We have pull requests that have been open for way too long. If I sort them by least recently updated, we can see there are pull requests from 4 years ago that can't be done because they're enhancements that will break things that currently work in NumPy or that we don't know how to do. So a good place to look for issues is either to go to the center of the issue stack, not the ones that are a week old, because people will jump on those pretty quick, and not the ones that are very old, because the reason they're there is there are two that we can't fix them, but to look at ones that are maybe 3 or 4 months old or maybe a year old. Okay, let's take a look at how, if you're the one who jumps on the issue first, how you might actually attack it and try and fix it. And this actually happened. We had a new contributor come along and pick up this issue that someone posted about 3 weeks ago. And we'll try and take a look at what this person did to push this issue and try and fix it. So this is how an issue looks when it first comes through the pipeline. A user comes up and says, hey, something's wrong. And they're trying to their best to give a description of actually what's wrong. So one of the first things you have to do when you're triaging an issue is look at it and try and figure out what's going on here. What is the person actually trying to convey to the NumPy developers? And one thing you might notice in this issue is that it's not quite formatted correctly. The user didn't actually use the GitHub markdown code format to format their issue. And so let's help them out. That's something we can do as a triager, is to reformat their comments. And now we can actually see what the problem is, what's going on here. Okay, they do import NumPy as NP, that's pretty clear. Print out the version, that's 1.18.5. And then they do array3 equals np.arange, parentheses, start equals 5. And they print out array3. So that would be this line. Anybody see anything strange here? See what the problem is? Okay. We asked for start equals 5. What NumPy did was stop equals 5. Well, that looks bad, okay? If I ask for stop equals 8, then NumPy will output an error that the required argument start is missing. If you don't put anything in arange, if we go over to the documentation and look at it, I don't want to do that because I don't want to make you guys dizzy with flipping all my tabs around all the time. You'll see that you can do arange, open parentheses, close parentheses with nothing in the middle, and it will also yell at you that the start argument is missing. But if you put in one number, arange 8, for instance, that will get translated to stop, and that will print out 0, 1, 2, 3, 4, 5, 6, 7, 8 values. Okay, so we've kind of understood what this issue is about. There's two problems here. One is that for some reason start is being interpreted as stop, and the other less critical problem is that stop is when stop alone is put in, there is no start equals 0. Okay, so people started commenting. You'll see how long it took for someone to start commenting was actually no time at all. On the same day, someone had already commented, and the person came back and commented again. And then someone actually tried to look through the code to see when this broke. And then we discovered that actually it's not a regression. This code has been that way for 20 years, and no one's ever discovered it. So because of this comment here, that might be a nice thing for some newcomer to work on, a newcomer actually picked this code up and started working on it. And we can see that because later on in the issue, in the flow of the issue, there's actually a pull request here that comes to fix this. So let's take a look at the pull request. The first thing we see in the pull request is that it says it links back to the actual issue itself. That's the way that nice little link showed up in the issue, was because this pull request actually said, I'm related to issue 17764. So that's pretty important when you create a pull request. It kind of marks your territory. It says, I'm working on this issue. Please don't also submit a pull request to fix it. Okay. And what does the pull request actually comprise? what's in it. There are two files that changed. Okay, we'll not look at let's look first at the second file that changed, which was the test. So the first thing that this person did was write a very nice test of all of the different things that are currently untested in arange. For instance, there was no test that arange without any values comes out clean. There was no test for step equals 3, which is also an error, and so forth. And so this is the actual test for the issue that the reporter raised. And if we would actually check out this branch with only these tests in our repo and run the tests, we would see that they would fail. So the next thing the person had to do was find out where actually is arange implemented. And I'll just go into that in 2 minutes because I'm kind of running out of time here. But if we go back to the code, let's go back into the code, into the source, into the core, into the source, and into multi-array, which I said was where most of the code lives. There's one file that's called multi-array module. And if we look in this file for arange with double quotes around it, we'll see that somewhere along the line, way deep in the 4,000 lines of this file, there is a dictionary that maps names like arange to functions like array arange. Nested iterers is another function. It's mapped to npy iter nested iter. So let's try and see how this function actually looks. Is this where we want to be? And I'll just finish out this piece quickly not by confusing you too much with the C code, but by saying that, well, this looks like the right place because this has a function in it called parse tuple and keywords. So that's probably what's handling the input of this function. This is the place we want to start looking around, digging around to see where the actual bug might be. Okay, and as I said, it got complicated quickly. That's pretty much what I wanted to talk about. I'd like to take some Q&A now. Let's see what we can do with that. Just to summarize, my goal here was hopefully not to scare you off too much. You can use it at NumPy as a nice place to help out with. We could use help with documentation, tutorials, code, and DevOps. Anything you contribute would be welcome. And we don't have any questions. So now would be the time to ask questions or actually have another poll. I'm going to put up another poll. Where is it? The queued. Start polling to see how I did here. If you could fill out the poll and tell me if you think you're interested in contributing. If you need help contributing, we can help you out. You can reach out to us, either open an issue or comment on an issue, or reach out to us on the mailing list or in some other way and say, I'd like to get involved. I need a little bit of help to get started. We're happy to mentor people at the beginning and get them started with the project. Yeah. So that's pretty much what I wanted to say. If there's no questions and there's no comments on the chat that I missed, Reshama, sorry, I think I'll send it back to you. Question about GDB. Could you go over briefly the ways to use GDB with NumPy? So, Brian, are you using Windows or Linux? I can show you in Linux. I can't really show you in Windows. So, did my screen made itself smaller. Let me make this font bigger. The best way to work with GDB in Linux is you actually need to build a debug build of NumPy. So the way to do that is to clean it all out, git clean xfd. That cleans out all of the files that we built. And where we ran build tests before, now we're going to set up some C flags to do. Now this works on my computer. I've heard it doesn't work in other places. O minus G3. So these flags are, that's a capital O, and then a 0. That means don't do any optimizations. G3 means take care of all the macros that you want. Don't turn any of them, don't inline any of the macros, and show me all of the values for C macros. So now I don't want to actually run the tests. I just want to build NumPy. So I will do run tests py minus b, which is build only. This will build a debug version of NumPy, and I'll answer some other questions, and I'll show you, before I show you how to get into it while it's building. Do we need to be familiar with C language in order to contribute to NumPy? You don't. It helps. A lot of the code is written in C, and a lot of the kind of bent of the code reflects C up in the Python language. So things like D types really take a C kind of mind in order to understand why all of a sudden my D type is overflowing or my D type isn't behaving the way I want it to. But like I said, we could use help with documentation, with tutorials, with DevOps kind of things, as well as code itself. We'd be very happy to help people work around. We'd be very happy also to work with people who don't know C and to improve our documentation and our onboarding systems so that we'll be more friendly to people who don't know C. Okay, so, but I'll go back to C because to answer Brian's question. So the next thing you need to do is do GDB minus args Python run tests py minus Python, which is what I said before is a way you can get this whole thing to run under Python. And now we've opened up a GDB session. We can tell it to run. It's now running Python under GDB. Okay, so we've got a Python prompt. We can do import NumPy as np NumPy a3 equals a range to get back to the bug that we were looking at. Start equals 3. Never live code. Okay, and now we can stop. I'm going to hit Control C. Control C will bring me into the debugger, and I'll say break at array a range. I did a tab to complete the line. It sets a breakpoint because I compiled with the debug version. And now if I tell it to continue running, no, I tell it to continue, and I'll hit that code again. I have now stopped in the debugger at the array a range function. I think that's enough with GDB. For people who know GDB, this is enough to get you going. For people who don't, they were really bored from the past 3 minutes, so good. More questions? Chats. I'm on Linux. Okay, someone says they use GDB from CLion. Yeah, and there's some other good answers in the chat about pure Python things that could be improved. Yep, Great. Any more questions? Anything more?
Maddie, this was such a great talk. I can't overstate like how informative and useful it is on so many levels, not just for NumPy, but for Python, for debugging, for open source, for the history of it all. It was really just amazing, really. Thank you so much.
Thank you. I'll stop sharing my screen.
And, you know, this has actually gotten me excited about possibly doing a sprint with you.
Great. Yeah, like I said, we'd really love to onboard new people. You know, even if you onboard and you go somewhere else and work on some other library, that's fine. You know, that's great.
Yeah, that is great. That's sort of the, you know, the same thought I have with scikit-learn, where I have organized a bunch of sprints, which is like, you know, this is like for open source. If you go and contribute to another library, it's still a success. So, and a lot of this information is transferable with, you know, from one Python library to another with like slight, you know, specific tweaks. Okay, so with that, I will end this. This recording will be made available within the next 2 to 5 days. There's a comment here. If you look at our docs for contributing and find them confused or incomplete, we would also appreciate help there. That's from Melissa. Yes, and actually what I will do also is there's a bunch of links in this chat, which I have access to later. So I will copy all those links over to, you know, our transcript area. So it's available for people when they're viewing this recording later. Again, thank you, Maddie, and also thank you to the whole NumPy team. I know there were, you know, there were a lot of other people that you had collaborated with as well. So thank you so much.
Yeah, bunches of them were in the chat. So thanks, guys, for handling all the chat during the talk.